Hello everyone and welcome back to the session. So in the earlier section, first we have imported the libraries. After that we have done some data exploration. Then we have dealt with the missing values. So now in this session we have to encode the categorical data. So here we are selecting the columns with categorical data. So this is the command used for that. So these are the three columns with categorical data: sex, smoker and region. So let us check the unique value as well. So these are the two unique values in this column, that is female and male. So next we will check with the other column, dataset smoker unique function. So here the values are yes and no. Now let us check for region. Here we are having four values, that is southwest, southeast, northwest and northeast. So now let us check the data again. For that we are using dataset.head. So if I run that command, so this is our dataset. There are total 3 categorical columns and we have to encode all these categorical columns. To do that we will use one hot encoding. So for that, dataset equal to pd.get_dummies, in parenthesis data equal to dataset and drop underscore first is equal to true. So this will drop the first column after one hot encoding and to avoid the overfitting. So after this, now let us check the dataset again. So that's fine. So here you can see sex, region and smoker all are encoded, means they are converted into sex underscore male, sex underscore female, smoker underscore yes, region underscore northwest, east, southwest, like that. So this is indicating that we have successfully encoded all the categorical columns. Next, let us take the shape of the data set. So which shows that we are having 1338 number of observations with 9 columns in it. Next we will move to another section, that is called correlation matrix. Here we will be defining one more variable called dataset underscore 2, which is equal to dataset.drop. Here we have to drop the column, that is the variable, a target variable which we have to look for. So as we know that charges is the target variable, so we are dropping this one and execute. So dataset underscore 2 dot correlation with dataset specified column as charges. So here we are checking the correlation with the independent variable with the dependent variable. Here we have to specify the arguments, that is the size, which is 16:9. And the title is going to be correlation with charges with rotation of 45 degrees and grid lines, like grid is equal to true. And now we will be executing this. So as the command has done, you can see here the correlation matrix. This column is correlated with charges. BMI is also correlated. Number of children, sex, smoker, and even the southeast region is also correlated. This northwest region is not correlated. So similarly southwest is also not correlated. So here we are getting some more insights about this data set. Now let us move forward, and here we are defining a variable called dataset.correlation, that is core. So let us run this. Yes, we have defined this. Now we have to draw a heat map of a correlation matrix. For that we need to use this command plot.figure with figure size 16:9 sns.heatmap for correlation. Let us run this command. So this is the heat map that we get. So the lighter blocks are more correlated ones, like age, charges. BMI with the southeast region or with the charges. Similarly here smoker yes with the charges. Here this charges with smoker yes. So this is all about our correlation matrix. Let us move forward, and now we have to split the data set. So the next session is about splitting the data set. So before that we will be checking the data set. So that is dataset.head. So this is our data set. We are able to specify X and Y. So matrix of features, or we can say that independent variables. Before splitting the data set, we are able to specify X and Y. So matrix of features, or we can say that independent variables, X is equal to dataset.drop with column as charges. So here we have to drop only one column, which is charges. So here we are selecting the independent variables. All variables are independent variables except this charges, which is a target variable. So now let us define the target variable or a dependent variable. Y is equal to dataset charges. So here we have successfully defined the matrix of features and target variable. Now we have to split the dataset. So for that, from sklearn.model_selection import train test split. Here we have to specify the three important arguments in this class. So this is how we split this dataset into train and test dataset. First we have to specify X, that is matrix of features, and then Y, which is a dependent variable, and then test size as 0.2, that is 20%, and random state as equal to 0. So now let us run this command. Now let us take the shape of X train. So here there are total 1070 observations in the training set. Similarly for Y train dot shape, similarly for X test dataset, so that is 268 observations. Similarly for Y test, so that is 268. So we have successfully split the data into training and test dataset. So now let us move forward. Now we have to do feature scaling. For that, let us import this one, that is from sklearn.preprocessing, then import standard scalars. So first we have to create an instance of this class, that is sc equals to standard scalar, and x underscore train is equal to sc.fit underscore transform of x train. Similarly for x underscore test is equal to sc.transform with x underscore tested. So now execute this. So we have successfully applied feature scaling on x train and x test. Now you can see the range as well. So the range is from -3 to +3. So here part 1, that is data processing. So till now we have done few steps in our project, that is data pre-processing by importing all the libraries and the data set with exploitation, dealing with the missing values, and we have done with the categorical values. Then we have drawn correlation matrix, and after that we have split the data into X train and X test. And before that we have to define X and Y, that is the matrix of features and target variables. And at the end we have applied feature scaling. We apply feature scaling because we want all the independent variables on the same scale. So this is all about data pre-processing, and in the next session we will start to build the actual model.